Let's have a look at the conditions for either maintaining or reversing the direction of the inequality sign. For maintaining the direction of the inequality sign, we need to one of these two conditions. Condition number one, either we're adding or subtracting a constant from both sides, in which case the inequality sign is maintained. Or condition number two, if we're multiplying or dividing both sides by a positive number, the direction of the inequality sign is also maintained. So it just stays pointing in whatever direction it was pointing in previously. Let's just have a look at an example of this. So if we consider just a very simple inequality, 1 less than 2. Okay, we agree that that's true, of course. So if we draw a number line, okay, and maybe 1, 2, 3, 4, -1, -2, -3, -4. Okay, it's not to scale. So I'm just going to put two counters. Okay, so one at the red counter at 1 and the blue counter at 2. Okay, so if we're now adding and subtracting the same value from both sides, what happens to the counters? So let's say we're adding, I don't know, let's say we're subtracting actually. Let's say we're subtracting 2 from both sides. Okay. What inequality results from that? 1 minus 2, okay, is -1, and 2 minus 2 is 0. Is -1 less than 0? Yes, of course, because -1 is to the left of 0. What's happened is that both counters have now moved 2 places to the left, but they've moved 2 places to the left simultaneously. So the gap between the two counters is still the same, that hasn't changed, but both counters have now shifted. So think of, at least from a geometrical perspective, think of adding or subtracting a constant from both sides of an inequality, or even both sides of an equation for that matter. What happens is the counters or the objects actually move relative to each other. Okay, so if we're adding, for example, let's say we're adding 2, so plus 2 to both sides. What happens? Okay, again, instead of moving to the left-hand side, the counters are going to move to the right-hand side. So the red counter will end up at 3, okay, and the blue counter will end up at 4. And we end up with the inequality 3 less than 4. Now, what about multiplication? So let's say, for example, instead of say adding 2, we're going to multiply by 2. So I might just reset these counters on the number line. So put them back on 1 and 2. Let's now multiply both of these values by 2. Okay. What actually happens? What happens is actually a stretch. So it's like the counters get stretched apart from each other. So this blue counter is going to end up at 4. Okay. The red counter is going to end up at 2. Notice that the gap has now increased. The gap's doubled, in fact. So originally the gap was 1. Now the gap was 2. But the red counter, which represents the 1, is still to the left of the blue counter. The red counter hasn't overtaken the blue counter. And that's what's important, okay? So multiplying both of these numbers by 2, we end up with the inequality 2 less than 4, okay? The inequality is still maintained. We don't have to change the direction of the inequality sign. And again, the two counters relative to each other in terms of which one's in front of which, the blue is still in front of the red. Now let's have a look at the situation where the inequality sign is in fact reversed. And the rule states that when multiplying or dividing both sides of an inequality by a negative number, we reverse the inequality sign. So let's have a look at a similar inequality to what we looked at before. This time, 1 less than 3. Okay, we agree that 1 is in fact less than 3. So no one's going to argue that point. Let's multiply it now by -1 and let's see what happens. So what I might do is I might put the red counter here at 1 and the blue counter here at 3. Okay. Let's multiply both of these by -1 and let's see what happens. Okay. So what happens is that the 1 becomes -1. Okay. The 3 becomes -3. Okay. What's now happened? All right. The red counter is now in front of the blue counter. So in fact, you could think of it as a rotation, in fact. Multiplying by -1 is like a 180 degree rotation. Okay, so positive 3, it's like it's rotated 180 degrees anti-clockwise, sort of like the way the sort of sun rises and sets. Okay, positive 3, okay, rotates 180 degrees and becomes negative 3. Positive 1, again, rotates 180 degrees and becomes negative 1. But in doing so, in terms of the order of the counters, or the order of the values, they switch as well. Okay, so what we end up with a situation of negative 1 and negative 3. It's very clear that negative 1 is in fact greater than negative 3. Okay, so the inequality sign has to flip. And the same thing also happens for dividing by a negative number. So if we divide by negative 1, dividing by negative 1 is like 100, again, another 180 degree rotation, except it's clockwise, not that it really matters in this situation. But again, it's like flipping it 180 degrees. If we're dividing this by negative 1, the same thing happens. So divide by negative 1, divide by negative 1. Again, it's like it rotates back to where it was. So the negative 1 becomes positive 1, the negative 3 becomes positive 3, and the blue ends up in front of the red again. Okay, so we end up having to flip the inequality sign yet again.